Hi everyone, welcome back to the start.ng introduction to Go programming course. In this video, I'm going to write the guessing game. If you saw the last video, which is the introduction video, I said that I was going to do a second video that would cover writing the guessing game that I talked about during the class on yesterday. So let's quickly dive into it. Okay. After the last lesson, I showed you how to run your Go programs, build it separately, and run it. And this is the code, and hopefully you've already copied that out. So I'll just get rid of this and get into writing the the guessing game. Okay. So the way our game is going to work, so our game is gonna be basically a CLI application. All right. So what I mean by a CLI application is an application that will run in on the command line. All right. So there are different ways of writing command line applications in Go, but this one is going to be very basic. So we won't be doing any seriously advanced stuff. But hopefully the game is going to be fun. You're gonna see it. So let me start. So the first thing we're going to do is so we'll start with printing out the name of the game. So first things first, fmt.pln. Say let's call it just say guess the number, right? Guess the number. Okay. So print that out and then go ahead and say fmt.pln. Please input your guess. All right. Okay, so let me take a step back and explain to you what's going on and how I'm going to go about it. So basically, what I want to do now is we'll start by telling the user the name of the game, right? Now we will request an input from the user. So we are basically going to sort of receive input from the user's command line, and then we'll process that input and print it back. For now, that's what I'm going to do. So to receive input from Go, the first thing you have to do is to create a memory, some sort of a variable. So we can call it like a box, right? A variable is like a box any where you can store in anything. Okay. So to declare a variable in Go, you use the var. Okay. So there are multiple ways to define a variable actually in Go, but in this very scenario, we will use var because of the specific needs that we want. Okay. So we're going to call it guess. So this will be the name of the variable. So and it's going to be of type int. So this is variable declaration in Go. Var guess int. If you remember during the last video, I said something about statically typed languages being having to tell the compiler the type of variable that you want to create. So here it is. So guess is the name of a variable, and we are telling the compiler that it's going to be of type int. Okay. So as you can see, the Go compiler is already giving us warning. It says guess declared and not used. All right. So this is just part of the whole reducing opinionated thing in Go. In Golang, you're not allowed to have a variable defined that you don't use. Okay. So after defining the variable name, we'll go ahead and call the scan function from the FMT. So the scan function, what it does is it scans through your command line. Okay, so it's usually called a standard in. Sorry, it's called a standard input, which is just um, um, the stream that brings input into your programs. Okay, so we'll pass that, we'll call the scan, and then pass the variable that we want to assign the value to. Okay, so what will happen is, once we start this program, we'll print out these two strings here, these two values to the console, and then we'll define the variable where we want to save the user's guess. All right, so we'll call the fmt.scan to bring in, or to read in the user's value into this variable here, so that we can use it subsequently in our program. Okay, so let's execute this program right now. So we can use go build main.go. That is done. And now run the main command. Okay, so something is not right. It's actually supposed to ask me to input my guess, so but it does not. Okay, let's troubleshoot it. And funny enough, there's probably an error somewhere, but because we are not checking for errors, there is no way to know. And because I don't want to bore you about the error checking right now, I just want to get this game working. So I'm just going to fix this without checking the error. But don't worry, subsequently I'm going to show you how to do all of that. Okay, so the scan function takes in what we call a pointer. All right, don't worry about pointers. Pointers is, or don't get scared about the word. So pointer is just an address. Okay, so it's just a memory address where some value is saved on your computer. So when Go defines this particular variable, it's assigned a memory address. So adding this ampersand tells the Go compiler to pass the memory address to the scan. So what scan will now do is, scan will read in the input from your command line and then locates the memory where this guess is supposed to be, and then adds this value right there. All right, so actually let me print this out so you see what I'm saying. So I can now say print line, let me just print f. I'll say you guessed, I send s, say guess. Okay, so let's try this now. Okay, let me just run this directly instead of building and running. So go run main.go. Yeah, so as you can see, it stopped, it did not exit. So it's now asking us to put our input. All right, so I'm going to type 3 and hit enter. Yeah, so this is funny. That is because if you look here, you see there's already a squiggly line down here telling me that I'm using the wrong type. Okay, so printf is actually a known, print anything with f is very famous in the computing world. With C, every C-based language usually have this f stuff that makes it very easy for you to combine two texts together. All right, so I use an s here. So an s means that I'm expecting a string value to be added to this particular sentence or phrase. All right, but it is not, it's wrong because the guess is an integer. So to fix this problem, I just have to change this to a d. So this means digits. Okay, so let's run the code again. So input 2, yeah, so as you can see, you guessed 2. Yeah, so it means we are reading it successfully and we are printing it out to the screen successfully. Okay, so all right, speeding things up, we first of all, this percent sign here is because we are not printing a new line after printing out our message. So to fix that, we just add a \n, which just means a new line to in Unix. All right, so if we run this code again, guess 3, and there you go, see, it's gone. You guess 3. Yeah, so we'll have the basic skeleton now. So this will now help us know what the user guessed. So the idea is the user guesses a number and we check if that is the correct number, and if that's correct, we tell him he won. If not, he has to continue guessing until he gets the correct one. Okay, so now I'm going to paste in a blob of code here, and then I'll explain to you guys what all that is doing. All right, so again, don't be intimidated by anything that you see right now. It's just really basic stuff that you're going to get a hang of with time. All right, so I'm going to copy, just going to paste this in here. Just start comments here. So random number generator. So generate a random number. Yeah. All right. So sorry. So once I add that, I'm going to import these two packages. So we added two new packages from the standard library, the rand and the time package. So the run package is a package in the standard library that helps you generate random numbers and a couple of other usages too. So you can just Google this and see other things that you can do with it. So what's happening here is that to generate a random number, we need to provide some sort of entropy. Randomization is actually a famous, like it's very common problem in computer science that it's very difficult to solve, to find, and to get random, to get a very healthy undeterministic random numbers, you need what is called an entropy. So an entropy is like something that really varies, that is always guaranteed to be unique at all times. Okay, so we want to use something that has that behavior, and one of the things that has that behavior is time. Time is always changing. All right, though time is not a perfect entropy generator, because if you do two things at the same time in different parts of the world, you are likely to get the same time, all right, somehow, but don't worry about that now. Okay, so we can use time here safely because we're not really doing so many very critical things at right now. So for now, time will do. So what this does is we just generate unique timestamp in nanoseconds. Okay, so you can pause and read this here, see what unique time actually means, and you can Google it to find more. So we use that to create a source. All right, so as you can see, it says new source returns a new pseudo random source seeded with the given value. All right, so it just generates a source, and then we can pass that source to the run constructor function, which is new. All right, so it will now return an instance of a random, so basically a randomizer. All right, so once that is done, we call randomizer.intn. So what this does is it will generate any number from 0 to the number that you pass in here. So we want to generate numbers from randomly. The numbers should not be less than 0 and it should not be less than 1. So let me just generate numbers between 0 and 10. Okay, so 0 and n. So just say 10 because that's what we passed in here. All right. By the way, in the previous video, I actually forgot to mention how to install an extent the Golang extension that would give you all this nice code completion and information about the code you're writing. So to do that, you could actually come to your extension tab. So you can click it. I think in the GUI there is an extension button here, but you can just run Control Shift X. So Control Shift X if you're on a Windows, but if you're on a Mac, you can just do Command Shift X. So let me write it here. So Windows, let's go ahead and say pressing Control plus Shift plus X. So if you're on a Mac OS, so say Command plus Shift plus X. Yeah. So you should open this extension tab for you. So you just type Go. So once you type Go, it's going to bring this out for you, and you just install this first one from Microsoft. Yeah, that's what I'm using, and it's really been working well for me. So once you install that, and everything should be ready. Okay, so let's proceed. All right, so we have our randomizer now. So what we can do is to generate a secret number, which is now ready. So now now you're probably seeing this and wondering what the heck is this. All right. So if you remember when I was defining this variable, I told you that there are many ways to define variables in Go. So you have const, all right? So const is for constant. You can say const guess, all right? Equals to blah, whatever. All right. So const is that it's for defining variables that would never change. Shouldn't change. It remains constant to the end, from the start to the end of the lifetime of your program. That's what const does. Okay. So, but this dot equal to, so this is just colon and an equal to joined together. All right, that's what it is. So it's used to define a new variable. All right, so it can only be used inside a function. If you're not inside a function, this is not, you can't use it outside. So sometimes if you come here and say source equals to nil or something like that, so it's not going to work. All right, see, non-declaration outside function body, see, so it's not going to work. So if you want this to work, you have to be like this, use a var. Okay, so what the colon and the equal to does is it does two things. It will declare the variable and also assign the variable with a value. So here we are just declaring the variable, we're not assigning any value at all. But if you want to do both at the same time inside a function, use this. Of course, we can also do something like this, equals to whatever we want. This should still work. All right, so don't worry about it. So this should still work out very well for us, you see. So yeah, that's not what we want to do. So let's just take it back. All right, so let's proceed. Now that we have our secret number, we can say you guess this. Then we want to check if the person gets right. We can say if guess is equal to the secret number, can go ahead and print PLN correct. You win. So else, just print something else. Sorry, wrong. Use. Okay, so let's run the code. Guess the number. Guess 4. Okay, we guessed 4 wrong. Okay, so I'm actually not printing out the correct answer. Well, we'll come back to that. Okay, so let's so as you can see, the way this thing runs is, well, it looks nice, but this is actually boring. So we need to make it a bit more interesting, and to do that, what I'm going to do is I'm going to make this run continuously. So we're going to we want to make it possible for the user to continue to guess and guess and guess, and we'll even give them hints. All right, so continue to guess until they guess the right one and tell them that they won. So practically nobody will ever lose in this game. Okay, so yeah, so let's do that. So let me get rid of this for now, come back to it, and also this too. Okay, so we'll start with creating a for loop. All right, so when we start treating the basics of Go, we will understand some of these terminologies. But for now, just see a for loop as a loop, something that continuously repeats the same thing until they tell you to stop. Let me just give you guys a classic example. So you see, so I'm going to write an infinite loop that says just print the same thing. So say infinite infinity. Okay. So if I run this code, oops, it's complaining about not using my CD secret number. Okay, let's just do this. Yeah. So again, don't worry about anything you're seeing now that is making you bite your head. This is just meant to be fun. I will explain them as time goes on. All right, so let's run the code. Okay, so for there you go, infinity. It's a loop. So I stopped that by running Control C. So Control C will stop the code from running. So this is infinite loop. It never ever stops until you tell it to stop. All right. So it's just a loop that repeats the same line of code over and over again. Okay. So now the first thing we want this loop to do is to tell the user to input their guess. All right. That's the scan. So let me move this thing down here so it's clear what we want to do. Please input your guess. Okay. So once the user does that, we can now check if he gets correctly. Okay. And so first of all, we'll check if he or she guessed the correct we'll check if the person gets the right one. If you get the right one, tell him, hey, you won. All right. But if it's not the correct one, we can check whether the number is bigger or smaller and give the user hints so that they can improve their answers and hopefully get it correctly. All right, so let's do that. So I'll just copy this from, because I already wrote this program and it's working. So let me just copy it over here instead of typing it out. I want to save some time. Yeah, so this is it. So I'll go through it line by line just so if you, okay, so let me bring this back. So secret number. All right. Okay, so here's what's happening. We ask the user to give us to guess. Once the guess comes in, we'll scan it into this variable guess. By the way, it's very important that you have this thing outside, this declaration outside, or else it will always be resetted on every run. So there's no need to have it inside. Okay. So if the guess is greater than the number that was randomly generated from here, we'll tell them that it's too big. So the user would know to get something smaller. Else if, so these are conditional statements in Go. We'll get to this as time goes on. Okay, so else if the guess is less than the secret number, we'll say too small. Else, which means that now, so if it's not bigger and it's not smaller, then it's probably the same. Then we'll just say, hey, you won. Okay, so let's execute this program now and see what we have. Go run in.go. So I'll guess too small. Okay, I'll go higher and guess 3. Still too small. Okay, let me come up and guess 5. Still too small. Okay, let's keep coming up. Guess 6. Too small. Guess 7. Too small. Guess 8. Yep, and I won. So I guess so. They will finally guess the correct number. So we can actually increase this to something like 100, to make it much more difficult. It means you now have to continuously guess numbers, and you can even do nice things like keeping track of how many guesses and limit that. If you guess more than that, crash it until you've lost. Like, there are so many things you can do, so let me leave that to you. So maybe after our introductory classes you can come back to this program and improve it. Okay, so I think that's that. I will make this code available for you with the gist. I'll create the gist on GitHub and post this with this video, and you can check the description and get the link to this code. You can grab it and play around with it. All right, thank you.